how do rocket engines work? Well, a rocket engine consists of two parts. The first part is a pressure chamber, which is usually just a cylinder. And the second part is some way for the material inside the pressure chamber to escape, which we call this a nozzle. And so we have the pressure chamber, and the nozzle. Now, diagrammatically, the way that we might draw that is something like this, where inside the pressure chamber we have a high pressure gas. So these arrows are representing the pressure inside the pressure chamber, and it's pushing against all of the sides of the pressure chamber. And outside of the rocket, we have a much lower pressure. The nozzle works to convert this high pressure gas to a fast moving stream of gas as it leaves, hopefully at lower pressure equal to the atmospheric pressure on the outside. What we want to do is we want to figure out how the nozzle converts this slow, high pressure, high temperature gas to a very fast, low pressure, cooler gas. It's still hot, but cooler gas. To do that, we're going to need to make quite a few assumptions, and we're actually going to make several videos in order to do this. So the first is, let's draw a sideways cross-section of our nozzle. The gas starts out here, high temperature, high pressure, low velocity. We're going to use U as a symbol for velocity. It's going to go through our nozzle, and on the other side we're going to have a low pressure, a lower temperature, and a high velocity U. The assumptions that we're going to need to make in order to do this are going to be the following. The first assumption: the motion of the gas is only in, let's call this the x direction, the x direction. The second one, the mass flow rate in the nozzle is constant. Third, the only forces on the gas is pressure. And 4, no heat is exchanged in the gas. Okay, so a few of these, this assumption is just made because the dominant direction of flow is in the x direction. Mass flow rate being constant should make sense if the same mass goes through here as comes out of this wide nozzle in the end. The only forces acting on the gas is pressure. So we say that I've got a low speed over here and a high speed over here, that the gas had to be accelerated through that from low to high speed, and the forces that are acting on it are the pressure. So the pressure on this side versus this side accelerates a little bit in the same way the whole way through, and no heat is exchanged in the gas. This process is extremely quick, and heat flow is not an extremely quick process. So we're going to say that this happens so quickly that no heat flows during the entire process. We're actually going to have several videos in order to explain all of these portions, but this lays out kind of the idea of what a rocket nozzle is and how it converts this high pressure, high temperature gas into the exhaust plume that we need, and the assumptions that we need in order to look at how this works.